Hi, good morning. So I hope that you are doing well. Okay. This is a lecture 2 of chemical reactions and equations, chapter 1 of class 10th. Okay. We already learned few basic things like when we'll say that a chemical reaction has happened. What is the difference between a physical change and a chemical change? Okay. And how we are going to determine that, or you can say find out that a chemical reaction has happened. Okay, now in this lecture we are going to learn further few things, like we are going to cover these topics: factors determining occurrence of chemical reaction. Okay, then we'll see the balancing of chemical equation, because balancing, what I feel, is like very we can say a very interesting topic, huh? Not a tough one, but yeah, interesting. Then we will see types of chemical reactions. These are not the you can say uh, all the chemical reactions, but the one which is, you can say, which are important, which are basic chemical reactions, we will see. And then we will uh, learn combination reaction in detail. Okay, and we'll see also the types of combination reaction in this lecture. Okay, so hello everyone, I am Ashutosh, and I am here to teach you chemistry for Ask IITians. Okay, so I hope that you are enjoying my videos. Let's start. Huh? So, first thing is factors determining occurrence of chemical reaction. As we already have seen, that a chemical reaction occurs when two reactants are going to come closer. Okay, so it means that if we have a reactant A and reactant B, let's say, so then the both are going to combine with each other, or interact with each other, you can say, to form C plus D plus E. Okay, like this we can write as the general chemical reaction like this. Now, so since the reaction is going to happen, if let's say there is no A and there is no B, so then there will be no reaction. Okay, so it means that the extent of reaction or the chemical reaction depends on the presence of, you can say, reactants. So it means that if let's say we have reactant A as only 1 mole, let's say, and reaction B as only 2 mole, let's say. Okay, so then the amount of C formed will be based on the initial amount of A and B. Okay, if let's say we have now 10 moles of A and let's say 17 moles of B, so then the concentration of C, or the amount of C which is going to form, okay, will be different. Okay, in first case some other amount of C is going to form, and in second reaction we'll have a different amount of C. Okay, so it means that the reaction, chemical reaction, depends on the concentration of its reactants. Okay, it does not depend on the concentration of product, because product is going to form from reactants, and that's why the chemical reaction, okay, the extent to which the chemical reaction proceeds will depend on the reactant concentrations. Okay, next, physical state of reactants and surface area. Let me explain this. Now we know that uh, any chemical reaction, okay, or any substance exists in either solid form or gas, let's write, and or liquid, like this we can write. Now we know that in solid the molecules are well arranged, okay, in a very nice manner. Okay, then in liquid they will have some mobility, okay, some random mobility on, okay, like this, while in gas the kinetic energy is very high. So in solid the kinetic energy is less, we can say Ke less. Okay, and here we can write Ke as highest. Okay, so since it has highest kinetic energy in gaseous form, so it means that whenever required, okay, or you can say when they are going to interact with each other, let's say a solid is interacting with b solid, okay, in first case, and in second case, let's say a gaseous is reacting with b gaseous. Okay, so in which of these two cases the chemical reaction will, you can say, be more we can say more easy to occur, huh? In gaseous phase. Why? Because in gaseous phase, when the molecules are in gaseous phase or the reactants are in gaseous phase, then there'll be more interaction. Okay, and that's why the extent of chemical reaction or the rate of chemical reaction or the amount of product formed will depend on the physical state of reactants or not. When the physical state of reactants is gaseous, okay, then the interaction will be much more than what the interaction was in solid phase or gas or liquid phase. And that's why gaseous reactions are violent, or you can say are going to occur very easy. Okay, now, so this was physical state of reactants. Now, surface area. Let's say we have surface area means the area of interaction. No? One reactant has this much of surface area, another reactant has this much of surface area. So when they are going to like come closer to each other, so then the interaction area, no, is very high. You can say this and this. Now, if let's say we have another case and where the surface area is very less, let's say this much only, very small, this much only, okay, and the other reactant has more surface area, okay, so then the interaction between these two will be less or not. So when lesser surface area is are interacting with each other, then lesser molecules are interacting. Surface area is like more surface area means more molecules, less surface area means less molecules. Okay, like let's take one example. Let's say there is one reactant, this one reactant, and there is another reactant, let's say like this. Okay, so this is the surface area, and let's say this is the surface area of b, which are going to interact with each other. So then as compared to this, if we have a very small surface area and this, let's say, large surface area, so then the interaction of this with this is very less or not. The molecules on this surface only are going to interact with the molecules of this. So it means that when surface area is less, then the interaction of different molecules of different reactants are less, and that's why the product form or the reaction will also be less. Okay, now the temperature, as we already, so I hope that you learned this and this understood already. Now temperature. So regarding temperature, now we know that temperature determines the kinetic energy or the energy which a substance is holding. Okay, like solids, any substance exists in solid form. Okay, so when solid form, it means that it will have a less kinetic energy. Okay, if it exists in liquid form, then it will have kinetic energy more than solid. Okay, and if it exists in gaseous form, that is, then it will have, you can say, even further more kinetic energy. Okay, so highest kinetic energy, you can say. So it means that it depends on temperature. When temperature is high, then kinetic energy is high. Okay, and when kinetic energy is high, then the interaction will be higher, and that's why the reaction will occur easily. Okay, so temperature increases, then reaction also, we can say, proceeds easily, like this we can say. Then presence of catalyst. Presence of catalyst means, we can say that some of the reactions are like, uh, let me tell you the presence of reactant like this. Let's say we have a and b. Okay, and A and B are not very comfortable with each other. Okay, let's take one example, are not very comfortable with each other, interacting with each other, reacting with each other, like this we can say. But if we bring in some C, okay, so now A can easily form bond with C, and B can also easily form bond with C, let's say. Okay, so if I'm going to show this to you, now this is C. Okay, A and B were not comfortable interacting with each other, but when they formed a bond with, let's say, A formed a bond with C and B also formed a bond with C, not like this. Okay, so this is chemical bond I'm showing, and this is C. Okay, and these are A and B. Now when situation like this occurs, then A and B now will get more time interacting with each other or not, and that's when they are going to form a bond with each other like this. Okay, leaving C. So it means that C is not going to take any part in chemical reaction. It is only helping A and B to come closer and react. Okay, so it means that if there was no C, then the reaction was tough. Okay, now just C is present only, and that is making the whole A and B, the whole reactants in, you can say, they are going to combine with each other, and that's how they are going to produce the product like this. Okay, so it means that C is very important in this reaction, and this C is called catalyst. Okay, catalysts are those substances which are not going to take part actively in chemical reaction. Okay, but they are going to help the reactants interacting with each other, or then to proceed to the chemical reaction. I hope that you understood all these factors which are responsible for a chemical reaction to occur. So okay, so again I'm going to revise it. Chemical reactions, for chemical reactions, reactant concentration is important. If more reactant concentration is there, then the reaction will be more. Physical state of reactants, physical state, when I say, so then we learned that in gaseous phase the reactions will be, I mean, like, easy to occur as compared to liquid and as compared to solid. Okay, surface area, I also like explained this surface area concept to you. Then temperature, we learned that when temperature is high, then there'll be more chances for a chemical reaction to occur. Okay, uh, like this very important, we all have seen, no, this turning milk into curd. This is a chemical process. Okay, now when it is a chemical process, so we already know that if the temperature of milk is less, temperature of milk is less, like it, we put the milk in a refrigerator and all, so then it is not going to, you can say, turn into curd or something. But when temperature is high, so then this turning of milk into curd happens. Why? Because temperature is high, and that's why this reaction occurs. Okay, all these lactose will get converted into lactic acid and all. Okay, now presence of catalyst, we also learned this, like A and B are not comfortable interacting with each other, but in presence of C, they are, okay, they're going to interact with each other to form the product, and that's how we'll say that chemical reaction has happened. Clear? Now moving to the next slide, balancing of chemical reaction. This is a very important and very easy also, uh, um, it's a concept in which we learn the law of conservation of mass. Okay, what is law of conservation of mass? Let's see, law of conservation of mass says, law of conservation of mass. Law of conservation of mass says that mass can neither be created nor destroyed during a chemical reaction. What does this mean? Okay, mass can neither be created nor destroyed when during a chemical reaction. It means that whatever be the mass of reactants before the reaction will be equal to the mass of product after the reaction. Let's see. So let's take, we have one example, let's say, where nitrogen is reacting with hydrogen to form ammonia. Okay, so this is like one reaction, very small, very easy reaction, very basic chemical reaction, we can say. Now see, we have two nitrogen atoms on this side and two hydrogen atoms on this side. Okay, and here a total of four atoms on this side. Okay, one of nitrogen and three of hydrogens. Now we all know that all these elements are going to exist in atomic form. Okay, like nitrogen will be a bigger atom as compared to hydrogen, let's say. Okay, so one nitrogen atom will have a mass of 14 AMU, we know, and one hydrogen atom will have a mass of 1 AMU, we know. Okay, so 14 AMU and 1 AMU, like this. Now I was saying that if, let's say, we took two nitrogen atoms only. Okay, so then we'll have a 28 AMU mass or not, while if we take two hydrogen atoms, so then the mass will be 2 AMU only. Okay, it means that all these atoms of all these elements will have their characteristic masses or not. Like we cannot have 25 AMU mass when we are taking only nitrogen atoms. Nitrogen atoms, if we are taking, then the mass will be either 14, okay, or 18, or 28. Okay, like in multiple of 14 only nitrogens will have masses or not. Okay, so it means that all these atoms are representing some masses. Okay, some, or you can say there is some mass associated with each of these atoms. Okay, so now, so we have here we have two nitrogen atoms. Okay, and here we have, on the product side, we have only one nitrogen atom. Okay, so why this is happening? Let's see huh? We are going to learn this into detail. So like I'm going to write like this. Okay, so this is N and N. Nitrogen exists like this. In nature, nitrogen exists in form of N2, two atoms together. Okay, and hydrogen is going to, I'm going to show hydrogen with, let's say, blue color. Okay, like this. So this is one H, this is one H. Now when reaction is going to happen, so then we are going to provide some heat. Okay, when heat is provided, so then this bond is going to break. When this bond breaks, so then we'll get two nitrogen atoms or not, two nitrogen atoms. Okay, now the valency of nitrogen is 3, so it means that it is going to form 3 bonds. Here in N2 we have two nitrogen atoms like this. Okay, have a triple bond, and while hydrogen will have a single bond like this. So if we are going to break these bonds, so then nitrogen will come like this and like this. So it will have a valency of 3. Both of these nitrogens will require three different monovalent atoms to complete their, you can say, valency. Okay, now hydrogen is monovalent. See, hydrogen has only one bond. Okay, while nitrogen is trivalent, so nitrogen can form 3 bonds. Okay, so then we are going to break this bond. Okay, like this. Okay, so when this bond breaks, so then two H atoms are going to form or not? Two H atoms. Okay, so we are going to, yes, one H atom here and one, arrange H atoms like this. But still we have incomplete valencies of nitrogens here, you can see. So then we are going to take another H2 molecule. Okay, and then another H2 molecule will have also its bond are going to break. So then we'll get 2 more hydrogen atoms. Okay, so one hydrogen atom is like at here, and then one hydrogen atom at here, at this location. Now still that this nitrogen has two valencies left, so we'll again going to take another H2 molecule. Okay, again going to break this, and then we'll get two hydrogen atoms. One is going to make a bond with nitrogen like this, and another is like this. So now we have uh, all these nitrogens have this complete valency now. Okay, now let's see. So we can say that how many moles of how many molecules of N2 are reacting, taking part in reaction. Only one. See, only one molecule of N2 is taking part in chemical reaction, while in H2 this is one molecule of H2, this is another molecule of H2, and this is third molecule of H2 or not. So we can write one N2 is reacting with three H2. Okay, three H2 molecules to form how many NH3s? See, this is one NH3 and this is another NH3. So we can write two NH3. Now let's see the law of conservation of mass here. So how many? What is the mass here taking part in chemical reaction for nitrogen? So we have two nitrogen atoms. It means 28 AMU. So we'll write 28 AMU. Okay, then one H2 will have like 1 and 1 2 AMU associated with it, and we have three H2s, so we'll have a total of 6 AMU or not. Okay, and then what is the, so it means that a total mass of 34 AMU is on the reactant side. Okay, now present on the reactant side. Now in the product side, let's see. So what is the mass of this one molecule of NH3? Let's say. Huh? So one molecule of NH3 will have 1N, that is 14 AMU. Okay, and three hydrogens. So 3 into 1 AMU. Like this we can write. So it means that 14 AMU plus 3 AMU. So it means 17 AMU will get. Okay, now so 17 AMU here and 17 AMU for the second. So it means that a total of 34 AMU mass is present there on the product side. Okay, so now 34 AMU was present on the reactant side, and 34 AMU is present on the product side. So it means the mass before the reaction and mass after the reaction, okay, is same or not. So that's why this is called law of conservation of mass. First thing. Second thing, if we, how we are going to like, then we'll have to remember the masses and all these things. No, we just need to balance the number of atoms for each element on the reactant side to the number of elements for each reactant on the product side. Like if we want to write nitrogen, how many nitrogen atoms are present on this side? 2. Okay, how many hydrogen atoms are present on this side? 2 atoms per molecule, and there are 3 molecules. 2 atoms per molecule, and there are 3 molecules. So 3 into 2, 6 atoms. Okay, clear. Now on the product side, let's see. So we have N. How many N? 1 N atom per molecule, and we have 2 molecules. So 1 N atom per molecule and 2 molecules. So it means 2 N atoms are present. Okay, and for H, 3 H atoms on, okay, per molecule, and we have 2 molecules. So it means 6 H atoms. So like this, we can say that balancing is easy. Huh? Okay. Okay, so then let's see. So we need to just balance the number of atoms of each element on the reactant side to the product side. Okay, and then the mass will also get balanced. And that's how this law of conservation of mass says mass can neither be created nor destroyed. Because then whatever be the mass before the reaction, okay, same will remain after, can say, the reaction completed. Sorry. Then next, types of chemical reaction. Now, types of chemical reactions are combination reactions, decomposition reactions, displacement reactions, double displacement reactions, oxidation reactions, reduction reactions, endothermic, exothermic. Okay, all these reactions are there. Okay, I'm going to explain these reactions in detail in coming lectures. Okay, so first let's talk about combination reaction. Combination reactions is like very simple reaction. Okay, like the simplest of all. In combination reactions we will have we can write A reacting with B to form AB. Okay, like simple. Reaction in which two or more substances combine to form a single substance are called combination reaction. Let's see the type of combination, like this: C plus O2. Okay, there was C, there was O2, and then they get combined together to form CO2. Okay, now types of chemical reaction: a combination reaction between two elements. Okay, we can say if we have, let's say, carbon. Okay, carbon exists as C only. Okay, and oxygen exists like O2, gas. Okay, so this we can write solid, this we can write gas, and then let's say we get CO2 CO2 in gaseous form. Now this is already balanced or not? One carbon on the reactant side, one carbon on product side, two oxygens on reactant side, two oxygens on product side. Okay, now if let's say we have C plus O2 to form CO, how are we going to balance it? It is balanced? No, not balanced. Okay, because one carbon on the reactant side, one carbon on the product side, two oxygens on the reactant side, while one oxygen only on the product side. It means that it is not balanced. So how can we balance it? So one way of doing it is like what people do is they are going to take only one O atom. No, one O atom we cannot take. Why? Because here we are going to write the molecules. Okay, compound or substances in molecular form. So oxygen exists as O2. Oxygen exists as O2. Okay, so we'll have to write it as O2 because O2 is only going to take part in chemical reaction. Molecules are going to take part in chemical reaction, like while writing it. Then the bond, okay, the bond is going to break, and that's how two atoms will get. Okay, so then what is we cannot change the numbers written on the, you can say, as the subscript. Okay, so if let's say we have 2 and 3 here, so this is called superscript, and this is subscript. Okay, so we cannot change this subscript in any chemical reaction. Okay, now, so what is the other way of balancing it? So we have two oxygens here, we'll put two here. Okay, now we have two oxygens. Okay, how? Because CO, two molecules of CO we are taking. Okay, and we have now two carbons, so we'll put two here. Okay, so now see, it is balanced. Two carbon interacting with the two oxygens to form two CO. Okay, like this. Okay, so this is a one type of combination reaction where elements, carbon exists as carbon solid, oxygen exists as O2 gas. So they are like elemental forms of these elements. Okay, so they are interacting with each other to form. This is called combination reactions. In combination reactions, one hint is there that the product will always be a single product. Okay, combination reaction. Combination reaction, it will be like A plus B, okay, interacting with each other to form AB. So we'll get only one product, or if we don't want to write AB, we can write C here. Okay, so always single product we will get in combination reaction. This is a hint, like we will get a type of questions, okay, which of the following reaction is a combination reaction. So we just need to check that in which of the given reaction there is only one product. Okay, so the one which has only one product will be the combination reaction. Okay, so these are the hints which we are going to, okay, how we are going to determine that which reaction type is this. Okay, now the next combination reaction between two compounds. If let's say two compounds are formed, so CaO here is combining with CO2, okay, and we'll get only one product, CaCO3. Okay, so that's how we are going to check this. Next, combination reaction between compounds and element. So this is compound, CO is compound, and O2 is an element. Okay, elemental form, although it is a molecule. Okay, but since only one type of atom is present, and that's why we'll say that it is elemental oxygen. Okay, elemental form. So O2 reacts with 2CO to get 2CO2. Okay, so let's check. See, here we had two oxygen atoms, and then two carbon, and then two oxygen. So it means total 4 oxygen and 2 carbons. And on the product side, we have 2 carbons and 4 oxygen. See, CO2. So 2 oxygen per molecule, and we have 2 molecules. So it means 2 into 2, 4 oxygen atoms. Okay, next. So this balancing of chemical reaction. So we already have done the balancing of both of these reactions, NH3 to N2 plus H2 and C plus O2 to CO. We can check this out. Okay, so like this, if we reverse this reaction, we can write 2NH3 to give N2 plus 3H2. Like this we can write. Okay, and we have also seen the CO thing here. So we already balanced it. Okay, now it says write a balanced chemical equation for the following information. An aqueous calcium hydroxide solution. Okay, so we'll write calcium hydroxide. Let me write it here. CaOH2, calcium hydroxide. Okay, aqueous. So we will write aqueous here. Plus react with carbon dioxide gas. So CO2 gas. Like this we can write or not. Okay, like this we can write. This will give us to produce solid calcium carbonate precipitate. So we'll write CaCO3 solid plus H2O water. Okay, now we'll see only one calcium atom on this side, only one calcium atom on this side. Okay, now how many carbons are there? So one carbon on this side, one carbon on this side. Now oxygen. So we have 2 and 2, 4 oxygens on this side. Okay, 4 oxygens on this side, and 3 and 1, 4 oxygens on this side. Okay, and then 2 hydrogens. So 2 hydrogens. So it is already a balanced chemical equation. Okay, so I hope that you got it. So like this we can write. Okay, so this is all for this lecture. I hope you enjoyed it. Okay, and if you have any query, post it on forum. We are going to answer all your queries. Okay, and keep learning, everybody, with Ask IITians. Thank you for your time.